Formatted console input output functions. So we have formatted as well as non-formatted or unformatted console input output functions. So what are the formatted one? We want something to be shown the way we want. The printf is what? It is actually showing, or scanf which is taking up. The printf is showing the things which are being given. Inside it, it has a proper format. That is, these are the list of variables and these are the format string. So this format string is known as format string because this format string is able to format the string and then show. The format string, they may contain the character that are simply printed as they are, or the conversion specification that you will see with %sign, %s, %d like this, %c. And then we have escape sequence that always begins with this slash sign, slash. We call it as a backslash sign. Let us take an example. If you just want to print the average and percentage, this is an integer, this is a float, and this average will, because this is simply printf. You want to print average, you want to print is equal to. Now this %d is not printed. This will actually replace average, which is the integer type, to %d. Then this slash n will also not be printed because slash n means the new line. Means if new line is there after this, the next line will start from here, not from here. Next content will start from here. Similarly, percentage is simple content or string, it will be printed, is equal to will be printed. But this %f, as soon as we receive or the compiler finds out the %, it will not print %f, but it will transfer the value which is after this to this point. So what you will see here, average, percentage, and these are the values which are being taken. And this is the, if you are dealing with Turbo C and C++ compiler, you will 6 after decimal 6 values. This is called the precision. So this is how it is being done. This percentage and this backslash sign, they have a special meaning. They say what to be done, but these are simply dumped. These are simply taken and being dumped on the screen or wherever you want. So we have format specifications. This %d, %f, all which you give in printf, these are called format specifiers. And they tell printf to do what? To show something that is integer, that is float, on the screen or on the file. So we have various data type, and what are the format specifier we generally use? This is being given as a C template. So we have integer, we have short integer. For that we use %d, %i. For short unsigned we use %u. Long unsigned we use %ld. Long unsigned we use %lu. Unsigned hexadecimal we use %x, and unsigned octal we use %o. For the real thing we use float and double. This is %f and %lf. For character we use signed character and unsigned character, %c for both. For string we use %s. We can also provide the optional specifier. For example, we have dd, then dot. So this dd means digits, which is specifying the field width. How much is the width? I'll just show you that example of that. But before that, you must understand this dd, and after this we have minus sign. So this is means this dd, which is preceded by minus sign. So this minus sign says that you have to left justify the output. While this dot, if you have dot, if you have a dd and a dot, so this decimal point separation field width from the precision. Precision is actually the value which is coming after the dots. How many values do you want? So let us see how to do that. We'll take an example before that. If you just write %d, it will show the way it has to be in a default manner. But if you write %10d, that means it will print the variable as a decimal integer, this %d, in a field of 10 columns. So there will be 10 columns in all. All these number of columns will be 10. And because by default it is justified on the right, this right justification is there. So if you always it will start from here. This number like goes like that. But you essentially want, no, I don't want it to start from here. I want it to start from here. For that you give -10d. This is for specifically making values start from the left, that is the left justification, and whichever area is left in this case or this case, that will be padded with a blank. Let us take an example. 63, you have %d, %2d, %4d, %6d, minus 6d. All this will be shown like this, and these are the numbers because they, this weight is just 63. So it will be just shown like this from 0 to this, wherever the content goes. But I'll give an example of exactly this, how this minus would work. Let us take this example. You want to show %f, %f, %f. Again, you have to show %f, %f, %f. But the way the output is like this. Now, this is not in very good order. Though the results are there, but %f is also there. You have a value which is followed by 6 digits, which is the precision value. And if no digit is there, you put a 0, or the compiler puts a 0. Now, you want it to be proper. For that, what you are going to use, you have to use 10.8. 10.1 means you want to give 10 values here, and then this dot, and then one value. So this 10 value, then dot, and then you have only this you want, 10.1. So when you find out the result, this will be 5.0, no problem with that. And this is a block, proper block. And it has started from, because this is right justified, this is not left justified. So this is right justified. It started with 0. It took three points, 3 values basically, three locations I must say. 0, point and 5. So 0, point and 5, 0, then point, that is decimal, and 5. All these are padded with a blank. Again, this is a 10 block, and this is a 10 block. So this is 10.1, this is 10, then point, then 1. So actually what is happening here is 10.1, so 10 location for this. In all it will be always 10, see, in all it will be 10 locations only. It will be 10 locations. It will not be, say, 10.1 you have said, so it will be 10 plus 1 plus 1, but that is 12 position. No. Otherwise, it would have gone to this value. No. Total in all, it will be 10. Then this will be point, and this will be only one precision value. So if you take this, or say take this, so only 9 will come. And rest 2 has already been occupied. Rest 8 places are given for these, and they will be right justified. So see, now the result is quite perceptive and it's looking good. So this format specifier can even be used for displaying a string of characters. Let us see that. We have some characters here, and this is some names. Now you want this to be printed as %20s. So you have given a block size, and the content is 20. The blocks count are 20. So when you see the result, you see from 0, from here to this point 10, then from this point to this point 20. So this is 20, and these all are right justified. So this %20s, it has reserved 20 columns, and in these 20 columns they are right justified. If you do it minus 20s, this s will come here, start from here, and this will be Sandy, and then this will be this block, or you can say reserved areas will be filled with the blanks. Similarly is the case with Ajay Kumar. Ajay Kumar, A will start from here till the time R reaches here, and then we have a blank.